Hi students, I am Mr. Pei. In today's video, what is the topic we are going to discuss today is regarding SPM Chemistry or SPM Physics. Before our discussion, please give me some encouragement. Subscribe my channel, like and share my video so that more students can learn and gain benefits from my teaching video. In this video, I am going to discuss with you the question in KSSM Physics Paper 3. The experiment I am going to discuss with you is one of the experiments in Form 4 Physics Chapter 6, Section 6.2, which is regarding the total internal reflection. This experiment is not listed in the compulsory experiment, but this is a very important experiment to let you understand the phenomenon of total internal reflection and together with the method to determine the critical angle of a glass block. Therefore, the experiment today, the aim will be to observe the phenomenon of the total internal reflection and also together with to determine the critical angle of glass block. This is an experiment which is listed in your textbook, page 242 to 243. Basically, the activity 6.3, as I mentioned just now, is to observe the phenomenon of the total internal reflection and to determine the critical angle of glass. So I think the experiment your school teacher is already conducted with you together. There are 4 important observations you need to know through this experiment, where the observation when I equal to 0, I less than C, I equal to C, and also I greater than C. Here is a summary of the activity 6.3. So where the I is known as the incident angle of the light ray in the denser medium, which is in glass block. When the I equal to 0, you may see that the light ray is not reflected. However, the light speed in the glass block is actually less than the light speed in the air. Second, when the I is less than the C is known as the critical angle of the glass block. So the light ray reflected away from normal in less dense medium. So that means you can observe in this figure, the R is represented as the refracted angle, and when light passes from the denser medium to less dense medium, the speed of the light decreases and cause the light reflected away from normal. So that means the angle of the incident is less than the angle of refraction here. And you can see there is a weak refracted ray appear here as a dotted line. The refracted ray will become sharper as the incident angle in the denser medium increases. When I equal to C, where R here at the less than medium, which is in the air, is equal to 90, the incident angle here we know as the critical angle. And the last important observation in this activity will be when I greater than C, you may see that the total internal reflection will be occur. So this is what actually you have already learned in your activity 6.3. Later on, I will show you the stimulation for these 4 observations in the question I already designed. Before we go to our discussion regarding the question I designed for this activity 6.3, I want to let you know there is 2 important things you have to know before your experiment. Firstly, you have to know the type of the question going to ask in the paper 3. So basically, there are 2 types of questions. It's about the Tugasan Amali berpandu. In Tugasan Amali berpandu, the procedure will be provided. So the candidate is just follow the procedure and diagram to conduct the experiment. And the second type of question will be Tugasan Amali tidak berpandu. So the procedure and diagram of the experiment is not provided. So the candidate have to plan the experiment and draw the diagram of the experiment. And this type of question is actually I already discussed many times in my channel. You may go to my channel and view back, okay, the discussion regarding the type of question. And in our question going to discuss today will be regarding the Tugasan Amali tidak berpandu. Secondly, you have to know the type of the experiment. So the type of the experiment is actually I've never discussed in my previous video regarding the discussion in paper 3. So there are actually two types of the experiment. The first will be the hypothesis experiment. So what is the hypothesis experiment? So the hypothesis experiment is involve the manipulated and responding variable in the experiment. So normally we are requested to get minimum 5 data. Okay, so that means we need to have 5 manipulated and 5 responding variable. And the question normally will ask you to plot the graph. Example of question or the experiment regarding the hypothesis experiment is here. We have two examples. The first is to study the relationship between the length and the resistance of the wire. And the question is actually I have already discussed in my previous video. Okay, maybe you can refer back to my video so that you can really clear that what is the hypothesis experiment. So in this example, the length will be the manipulated variable and the resistance will be the responding variable. So the question will request students to get 5 data and plot the graph. The second example is to determine the relationship between the force and the extension of the spring. So this is one of the compulsory experiment you actually already did together with your school teacher. And here the manipulated variable will be force and the extension of the spring will be responding variable. And 5 data you will be going to discuss in your experiment. Then the second type of the experiment is known as the non-hypothesis experiment. So the non-hypothesis experiment normally not involve any manipulated variable or responding variable, and no any graph will be plotted. So we have few examples here. The first one will be to determine the specific heat of fusion of ice. So here we do not have any variable here. So we just need to find out the value of the heat, specific heat fusion of ice, and to determine the value of the gravitational acceleration in activity 2.2 in Form 4 textbook is also one of the examples for non-hypothesis experiment. Then the last will be to determine the critical angle of glass block, which is the question we are going to discuss today. So that means that we will discuss the experiment which is in type of non-hypothesis experiment. And in my previous video, I've never discussed about the non-hypothesis experiment in my video. So this will be the first video which I discussed regarding the non-hypothesis experiment. So that means that in our question, which are going to discuss, will be a non-hypothesis experiment and Amali tidak berpandu, where the procedure is not provided. Okay, so let us go to our question today so that you're more clear what is the non-hypothesis experiment and Amali tidak berpandu. Let us read the instruction first. You are not allowed to work with apparatus in the first 5 minutes. This period is used to check the apparatus list, read the question, and plan the experiment, which is carried out. Mark in the box provided to check the material. So checklist for the apparatus and material provided will be these 5. The firstly is red box with single slit. 1. Semi-circular glass block. Power supply, protractor and ruler together with the white paper. So each with 1 quantity. So if you check all the apparatus in functioning well, so you may tick the checklist, and immediately you have to go to read the question. You have only 5 minutes to read the question and check the apparatus. As mentioned just now, there are two things you need to identify. First is the type of the question, whether that is a Tugasan Amali berpandu or Tugasan tidak berpandu. Then second is the type of the experiment, whether that is a hypothesis experiment or non-hypothesis experiment. So here you are required to conduct an experiment to determine the critical angle of the glass. So to determine the critical angle, so there is not the manipulated variable. As I mentioned just now, if there is not involved the manipulated variable or responding variable, this will be non-hypothesis experiment. Then we continue to our question. Plan this experiment using the apparatus and material provided. Your procedure should include method to handle the variable and the arrangement of the apparatus to conduct the experiment. So from here, we very clear that the procedure is not provided. Together, the diagram is also not provided. So this will be Tugasan Amali tidak berpandu. So these 4 marks, you need to include the method to handle the variable. So that means you need to write the appropriate procedure to the end of the experiment, which is to determine the critical angle. And then second, you have to draw the diagram regarding the arrangement of the apparatus to conduct this experiment. So total for the paper 3 will be 15 marks. This is 4 marks of the question. And normally if this is a non-hypothesis experiment, we need to read further so that we know the question actually want to ask what the question we have to conduct, and we want to observe or we want to determine one of the value here. So for here, definitely we need to determine the critical angle. So you can have a further reading for your question. So here you can see for B, carry out the experiment plan in A. Based on the experiment conducted, determine the critical angle of the semicircular glass block. Okay, so that means that you have to know how to determine the critical angle of the glass block, which actually you learned in your activity 6.3 in your textbook already. Then second, here draw and label your observation in the space provided based on the observation from the experiment in A. So here you need to draw your observation when the incident angle is equal to 0, less than critical angle, equal to critical angle, and greater than critical angle. So this is actually what you already learned also lah. The 4 important observation in activity 6.3. So your procedure must be include all the observation with different incident angle here. Here is actually the reference answer for the question A here, which you need to have a correct diagram for the arrangement of your apparatus to conducting this experiment, and together with the appropriate procedure, which including the 4 incident angle for your observation. So here, firstly, you have to draw lah. So the apparatus involved in your experiment. So you have to label white paper, your semicircular glass block, and the red box here. So the most important part is your curved edge of your glass block must be directed by the incident ray here. Okay, some of the students will be have a mistake where the incident ray directed to flat edge of the glass block. This will be wrong if you want to observe the total internal reflection and also to determine the critical angle of glass block. So firstly, you can just mention the apparatus is set up as shown in the diagram. Then the first procedure will be how you get your observation when your I is equal to 0. So we here, a light ray directed along the normal line through semicircular glass block from the curved edge. As I mentioned, you have to mention curved edge, okay? So the light ray that travel through the glass block is observed. This is the first observation, I equal to 0. Then second, you have to give the procedure for observation for I less than critical angle. So will be like this. The light ray moves slowly from normal line here to A to increase the angle incident. So the changes in the refracted light ray are observed. So be like this lah. Okay. Then the next will be the observation when I equal to C, and we need to determine the angle, the critical angle of the glass block, which is asked by the question just now I show you already. So how we measure our critical angle? So it will be like this lah. When the angle of refraction R will be here equal to 90 degree. So that means the refracted ray will be here. The angle incident will be known as the critical angle. So you have to measure your angle of critical from the normal line. The last will be, we need to give the procedure when I is greater than C. The angle of incident is increased further from the angle measured at step 4. And what happened to the light ray is observed. So your procedures must including 4 different angles, which is requested by the question, and you have to draw the observation in your question. So now we have already know the procedure. So we may start our experiment. And let me show you the stimulation for this experiment. So the simulation will be regarding to observe the phenomenon of total internal refraction and to determine the critical angle of glass block, which is requested by the question.
Hi students, I am Mr. Pei. In today's video, let us observe what is the total internal refraction, and together we want to determine the critical angle of the semicircular glass block. In this experiment, firstly you have to make sure that the apparatus you receive is same as the candidate checklist. There will be power supply, red box, together with signal slip, and we have the semicircular glass block, projector, ruler, and a piece of white paper. So again, you may check your apparatus to make sure that their all is functioning well. If your apparatus is not functioning well, you may raise up your hand and ask the new apparatus from the lab assistant or your teachers. And now let us start doing our experiment. Before to determine the critical angle of the semicircular glass block, we need to draw 2 important lines, a reference line and a normal line. So let me show you how to draw these 2 lines. Firstly, place the semicircular block on the paper and draw a reference line. And then, using a protractor, draw a perpendicular line to this reference line. Mark 90 degree. Mark a dot at 90 degree at the top of the line and also bottom of the line. the dot together, so you will get the perpendicular line of the normal line to this reference line. So and then now you have to label your normal line as 0. And now we may start our experiment. Switch on your power supply and connect your right wire of the red box to the power supply. And then the single slip face water and place in front of the red box, and a single light beam will be produced like this. Okay, now place your semicircular glass block and make sure the light is face towards the curved line. The curved line of the semicircle. So now you may start it. Firstly, place your semicircle glass block on the white paper, and the edge is on the line, on the reference line. First, directed your light beam at the normal line where the angle of the incident is equal to 0. And you can see there is no refraction occur when the light passes through the glass block. However, the speed in the denser medium, which is in glass block, is actually slower than the light traveling in the A. After that, the light beam is moving slowly from the normal line to A. So we try to increasing our incident angle. Make sure the light is strike at the center or the intersection point of the normal line and the reference line AB here. So here you can see that the incident angle here, I, is smaller than the refracted angle here. So from here you can see that when we're increasing our incident angle, so the light ray is started to refracted, and the angle of the incident increasing will also increasing the angle of refraction here. So now we need to determine, or we need to find out what is the angle of the critical angle for this semicircular glass block. So we will increasing our incident angle. So the incident angle is observed in the denser medium. Because to determine the critical angle, there is two conditions where the light beam is traveling from denser medium to less than medium, which is A here. Second, you can see when the refracted ray at the less than medium, which is in the A, is 90 degrees, the incident angle here will be known as critical angle. So the critical angle is almost here. So you can see here the refracted ray is 90 degrees from the normal line here. So our angle of incident here now will be known as critical angle. So we have to mark and draw with the line. Okay, so we measure by using our protractor. So place our protractor. Okay, make sure you measure your angle from normal line where the angle is equal to 0. So from here, my reading here is almost, you can see is 40. So I already get my angle of incident. Now is 40, where E is known as critical angle. When the refracted angle, when the refracted ray is, when the refracted ray is equal to 90. Okay, it's almost here. Then next, the angle incident now is increased further, which is greater than critical angle. So you can see the refraction is occur. There is no more any refracted ray appear or pass through the glass block. So now there is only refraction occur, and this phenomenon is known as total internal refraction. So through this experiment, there are 3 important things you need to discuss. Firstly, you can see there is no any refraction occur when the angle of incident is at 0 degree. However, the speed of the light in the denser medium, which is glass block, is higher than the speed of the light in the air. When we increasing our incident angle, we may see there is a refraction occur, and the angle of the incident here, you can see is smaller than the refracted angle. So I is smaller than R. Okay, so you can try to measure if you want. So here, this is the incident angle, and here, this is the refracted angle. So we measure. So our incident here is about 16. Okay, then our refracted angle. Okay, we measure and we get here is about 24. So our refracted ray will be 24. So that means that when our incident angle less than critical angle, refraction will be occur, and the angle incident will be smaller than the angle of refraction here. When we keep increasing our incident angle, so the angle of refraction will be also increasing. This is the second observation. Third, when we increasing our incident angle, which is still less than the critical angle, you can see the refraction angle is sharp and the weak refraction line is appear here. So when the incident angle reach our critical angle, which is almost 40, just now I measured. Okay, so you may see there is a refraction line at 90 degree. So the angle of incident now is known as critical angle. So here you can see there is a refraction line, refracted ray. You may see there is a refracted ray at the 90 degree at A. So or you can see the refracted ray is at the boundary between the glass block and the A. So when we increase further the angle incident, which is greater than critical angle, there will be no more reflection occur, and total internal reflection will be occur here. So this is the fourth observation. Okay, that's all for my sharing.
Okay, so I think you have already watched my stimulation regarding this experiment, and you must already very clear that how you conduct this experiment. So now, after the experiment, you have to immediately to complete your question, because marker will be see your question only, and he or she is actually to know how you conduct the experiment. So the answer is the most important for your paper 3. Okay, so this is question A, which the answer I already discussed with you, the method together with the diagram. So the diagram will be 1 mark, and the procedure regarding the 4 observation will be 3 marks. So this will be the answer just now I discussed with you already. This will be the first mark for the diagram, and the 4 step here where I equal to 0, I less than C, I equal to C, and I greater than C must be including in your procedure to get full marks. So for B, carry out the experiment planned in A. Based on the experiment conducted, determine the critical angle of the semicircular glass block C here. 1 mark. So as I mentioned just now, we have to measure our angle. Will be probably like this. So when the refracted angle equal to 90, so the critical angle will be here, and you have to measure, and the value I get will be 40. So the smallest deviation for the refractor will be 1 degree. So from here you can see, here the smallest deviation will be 1 degree. So you no need to give any decimal place for your answer, unless when the light ray is between the smaller division over here. So you can give the answer 40.5 degree. So it is impossible to get 40.1, 40.2, 0.3.4. You are only possible to get 40.5. Or you can actually, using the answer, maybe it will be 40 or 41. If you get your refracted ray, sorry, your incident ray at the line between 2 smaller division. And next, draw and label your observation in the space provided based on the observation from the experiment in A. So this is what you observe in your experiment. You may immediately draw your observation when you already see your observation in your experiment. Then when I less than C, will be like this lah. Here this is an incident ray, this is a refracted ray, and you can see this is a weak refracted ray. So here is a sharp refracted ray, and here will be a weak refracted ray. So the importance parts here will be the incident angle here must be smaller than the refracted ray here, refracted angle here. So the I must be smaller than C. As I explained just now in the simulation, this due to the speed of light will be increased when the light traveling from denser medium to less than medium. Then next will be observation for I equal to C. So where the refracted ray, the refracted angle here is equal to 90. So our incident angle here will be known as critical angle. So the refracted ray will become sharper. Okay, so here will be incident angle, which will be known as C. Okay, so here we have also one refracted ray. And our this refracted ray will be 90. Then the last, when the incident angle greater than critical angle, this line is a critical angle. So you can see the total internal refraction occur here. So you will see only refracted ray, no more any refracted ray. So you will not see any refracted ray again. So this is the answer for drawing, which is 6 marks. First mark for this I equal to 0. 2 marks for second diagram. Then this also 2 marks. This will be 1 mark. Next, question B1. Based on observation table at 2, compare the incident angle of light ray at a medium with higher optical density. So that means here will be glass block, and refracted angle of the light at medium with low optical density. So here will be at A lah. So with the angle of incident is less than critical angle. So that means the question asking you to compare the I and R when your incident angle here is less than C. So here the refraction occur. And as I mentioned just now, the angle of the incident here where I measure in the experiment and I show you in the simulation, which is 16, and your refracted angle here is 24, which is greater than incident angle. So the answer, the incident angle of light ray and denser medium is smaller than the refracted angle at lower denser medium lah. So the answer is smaller than. So you get 1 mark. And next will be B2. Explain your answer. So why the incident angle is less than the refracted angle here? Why? So my stimulation just now, you also explained to you already. This is due to the speed of the light in the denser medium or higher optical density medium, which is glass block, is actually slower compared to the speed of light at less than medium or low optical density medium, which is air here. So the light refracted away from normal. So the angle of the refracted ray will be greater. So here you have to discuss the speed. So the speed of the light increases when the light travels from a medium with high optical density to medium with low optical density. Okay, so this will be the answer. So we go to our next question. So then the phenomenon occur when the light travels from medium with high optical density, so will be glass block, to medium with low optical density, so here will be A, with the angle of incident is greater than the critical angle. So here, when our incident angle greater than our critical angle, so total internal refraction will be occur, which I already show you in the simulation. So the phenomenon we know as total internal refraction. Here will be 1 mark. So the next will be Name one phenomenon in daily life that involves the answer in one. See one here will be here. So you have to give example of total internal refraction in our daily life. So this is actually you also already learned in your Form 4 section 6.2. So here, this is one of the example. Mirage, okay, will be occur, and another one will be the rainbow formation here. So here is 1 mark. So you only need to give one answer here. So you may give mirage or rainbow here, or others appropriate answer also okay. Okay, so this is the total 15 mark I designed for this question regarding the activity 6.3, which is regarding the total internal refraction and how to determine the critical angle. If you think that the video is benefit to you or your friends, please subscribe my channel, like and share my video so that more students can learn and gain the benefit from my teaching video. That is all for my sharing today. Goodbye.